Alright, let's turn to the problem set on discrete probability distributions, and you can see I also opened an Excel sheet because we need to calculate many things using Excel. So let's start with question 1. A multiple choice test has 30 questions and each one has 5 possible answers, of which one is correct. If all answers were guesses, find the probability of getting exactly 4 correct answers. Okay, so first thing we need to know is this a binomial or is it a Poisson, hypergeometric or negative binomial? And of course it's a binomial because the event is it's a Bernoulli experiment. There are only 2 outcomes, either you get it right or not, and the success probability is 0.2. So, and we have 30 trials, and we want to know what's the probability that we have x equals 4 successes in n equals 30 trials, when the success probability p, okay, there are 5 questions, so 1 over 5, 0.2, and the exactly tells you we don't want it cumulatively, so in Excel it would be a 0. Okay, so what do we get? Excel, we will say binom.dist, number of successes, exactly 4, trials 30, success probability 0.2, and cumulatively yes or no, 0 for no. So now we should see an answer like this, and it's B. Question 2, a process is characterized by the following. Only 2 mutually exclusive possible outcomes, which are called success and failure. The outcomes in the series of trials or observations constitute independent events. The probability of success in each trial, denoted by P, remains constant from trial to trial, so that the process is stationary. This process describes a blank experiment, rigatoni, spaghetti, carbonara, Bernoulli. Well, that's obviously a Bernoulli process. Okay, 3. Which Excel function computes hypergeometric probabilities? Well, that's hypergeom.dist. A researcher needs 4 positive lab results with a success probability of 0.3 each. What Excel formula gives the probability that exactly 6 failures occur before the 4th success? Okay, I think it's clear that this is the negative binomial distribution. And well, we can actually ask Excel, so equals neg binom.dist, number of failures, gives the probability that exactly 6 failures, number of successes 4, the success probability is positive 0.3 and not cumulative. So what you see here should be the answer. So this is 6, 4.3 and false. Yeah, that works. And here C, no, it should be 6, 4, so it must be A. 5. Find the cumulative Poisson probability for P equals 3 or less with lambda 2 in Excel. You would use, okay, So we would use equals Poisson dot dist. Okay, 3. What's the mean? Lambda is 2. And we wanted cumulative. So, because we want 3 or less. So that's 1. So we have to look for Poisson. 3, 2. And that is B. And if you press enter, we also get the probability, but nobody asked for that here. Okay. So next one, an email server receives spam at an average rate of 10 messages per hour. Okay, that already hints towards a Poisson. You want to find the probability of receiving at most 7 spam messages in the next hour. Which Excel formula is correct? So it has to be the Poisson distribution. So it is B. So we would say Poisson dot dist. Okay, 7. Then the average is 10 and cumulative, all true. The probability would be 22%, by the way. Okay, 7. Which of the following scenario is best modeled by the hypergeometric distribution? The number of heads in 10 coin flips. No, that would be the binomial. The number of accidents at an intersection per month. No, that would be probably more Poisson. The number of women selected for a committee of 4 chosen from a group of 6 men and 4 women. Yeah, that sounds right, because that is obviously drawing without replacement, because once you are selected, you are not going back. So that is definitely C. The binomial distribution is characterized by situations that are analogous to drawing balls from a bowl. No. Coin tossing. Yeah, that's what we refer to several times. Counting defects on an item? No. Measuring the length of an item? No. Which of the following correctly describes the negative binomial distribution? A. It counts the number of successes in n fixed trials. No, that would be the binomial. It counts the number of trials until the rth success occurs. Yeah, that sounds pretty right. It counts rare events over fixed time interval. No, that would be Poisson. It counts successes when sampling without replacement. No, it's B. The hypergeometric distribution differs from the binomial distribution primarily because the hypergeometric distribution only applies when p equals 0.5. No, that's bogus. Sampling is done without replacement, so trials are not independent. No, that's also wrong. Because the only case where we have without replacement, that's the hypergeometric. The hypergeometric distribution has no fixed number of trials. No, the hypergeometric distribution applies only to continuous data. Okay, now I misread something. The hypergeometric distribution differs from the binomial. Oh, okay. So in the sense that sampling is done without replacement, so trials are not independent. That's correct. Yeah, I was somewhere else with my mind. Okay. 11, a customer service center receives phone calls at an average rate of 3. Okay, so that already signals Poisson. Which probability distribution should be used to model the number of calls received in a given hour? Now, whenever something is per space or time interval, it's the Poisson. To find the probability that x is 3 or less using the hypergeometric distribution in Excel with n equals 7, k equals 10, and n equals 30, you would set the cumulative argument to true. That's the one. Okay. A box contains 10 red and 15 blue marbles. If 6 marbles are drawn without replacement, which distribution models the number of red marbles drawn? Without replacement, we immediately know hypergeometric distribution. Which of the following is not a characteristic of the Poisson distribution? Again, Poisson distribution is it's a rare event. We know the average over space or time, and the events are also independent of each other. The average rate of occurrence is constant, that's also correct. There is a fixed number of trials. No, events are counted over fixed interval. No, there is no fixed number of trials. You know, it's like a typical example would be how many accidents may occur at an intersection over a year if we know the average rate is 20. Well, theoretically it could be a very, very high number. There's nothing fixed. Okay, so now let's move to 15. For a hypergeometric distribution with population n equals 20, successes in population 8, and a sample size n equals 5, the mean number of successes in the sample is. Okay, so there is a formula for it. But whenever you have a problem like this and you don't know the formula, there is a way we just can simulate it. Okay, so what do we have here? For a hypergeometric distribution with population n equals 20, successes in the population are 8 and the sample size is 5. The mean number of successes in the sample is. Oh, okay. So okay. So in a hypergeometric distribution with population n equals 20. Okay. So let's just approach this logically. So in the number of so there are a total of 8 in a total of 8 successes in the population, and we draw 5, but it is without replacement. So it's definitely 5 times something. Okay. And what do we have here? 5 times 8, 40 over 20, so that's 20. So in the hypergeometric distribution, so we have no replacement. Okay. So we draw 5. Well, in the first one, we definitely have a probability that we get 1, which is 8 over 20. So that should be correct. So, okay, but of course, after the second one, it would be 4 over 7 over 20 or so. So let's take a look at this distribution and let's take a look at what we get if we do it. But I'm very sure the correct answer is 40 over 2, which is 2. Okay, so we have a hypergeometric distribution and we have a sample size of 5 and there are 8 in the population. So what I would do when I have a problem like this, I would actually look at the distribution. And so how many successes can I get? So my sample size is 5. Okay, so I can get 0, 1, 2, 3, 4, or 5 successes, right? Okay, so let's calculate the probability for each. Okay, so we use the formula hypergeometric distribution, sample successes, okay, could be 0. Okay, the number sample, that's 5. Then the population successes is 8. And the population number is 20. And I don't want it cumulatively, so that's 0. Okay, so that's 5%. Now let's copy this down. And we can't really see it, but actually let me pull that up a little bit. So the sum, all events are now equal to 1. Okay, so now what is the expected outcome? So what we do is we have to multiply each success probability times the probability and then sum it up. So what I do is I do here P times success. Okay, so this is 0 times this. And I do that for all the others. And now if you sum that up, that should be the mean. And you see the sum is 2. Because the mean can also be written as the probability of, or the sum of I equals 1 to n, where we have the probability of I times whatever the value xi is. It's exactly what we did here. So we can get either 0 success or 1, 2, 3, 4, 5. When we multiply each with their success probability that we calculated specifically, well, then we get the expected value. So in other words, even though I don't know this formula, it made sense from looking at it, but I could only be sure that this is the correct answer from replicating it and calculating for each possible outcome the probability and then multiply each possible outcome with the respective probability and just sum it up. So the answer must be B. Okay, 16. Which Excel function computes negative binomial probabilities? Okay, so that's neg binom.dist. 17, in neg binom.dist, okay, the number of failures until we reach a certain number of successes. When the success probability is P, cumulatively, what does the parameter F represent? Well, the number of failures before the rth success. The geometric distribution is a special case of the negative we didn't do the negative distribution, so let me just delete that one here. We didn't talk about it. Let's continue. The Poisson distribution is most appropriate when sampling without replacement from a finite population. No, that sounds like the hypergeometric. B, counting rare events over a continuous interval. No, that would be the Poisson, so B is Poisson. So keywords for the Poisson is always space interval, time interval, rare events. The number of successes and a fixed number of Bernoulli trials, so that's binomial. Modeling the number of trials until the first success. No, that would be a special case of the negative binomial. And in fact, that would be the geometric here that I just deleted. The geometric is a specific case of the hypergeometric, where we look at the number of failures until the first success. A quality inspector selects 5 items from a batch of 20 items, of which 4 are defective. Which distribution is appropriate to model the number of defective items in the sample? Okay, so quality inspector selects 5 items from a batch, probably without replacement, and 4 are defective. Okay, that is clearly hypergeometric. You use the 1 minus Poisson distribution for 3 in Excel. Okay. Okay, that's a good question. So this computes. Yeah. Okay, so that's B, right? So let's just write it down. So that's a good question. So let's first start with the Poisson dist. Okay, so when we have equals Poisson dot dist. Okay, so the 4 events when the mean is 3 and true, which is cumulative. So that gives us the probability that there's an 81% probability that we either observe 0 or 1 or 2 or 3 or 4 of these rare events when the mean is 3. So that means 1 minus Poisson, which is the 18 point something percent, but that's the probability that we observe 5, 6 or 7. So that means B is the correct answer. Okay. So yeah, let's see, maybe before the video gets too long, how many do we have? So 40. Okay, so now we are at halftime. Let's maybe make a little break here and then continue with question 21 in the second part, and make sure that the videos don't get too long. So I'll see you in the next part.